Namaskar. In this series of lectures, we will be discussing the number system. Now, in our syllabus, we will have to discuss something about the binary number system, the conversion of decimal number to binary number and binary number to decimal number, hexadecimal number system. But as we have discussed, we will go through one more number system which is known as octal number system. Now before that, what is the number system? Now fortunately we are familiar with the decimal number system. Okay. Now the word decimal stands for 10. Therefore, our normal number system, that is the decimal number system, is the number system in which the base of number system is 10. What is the meaning of base of the number system? It indicates that there are 10 distinct numbers. That means suppose we will have to count something, then how many discrete numbers are there? In our decimal number system, there are 10 discrete numbers beginning from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. That means the base of this decimal number system is of 10 discrete numbers, separate numbers. Then how we can continue the counting after 9? See, suppose there is a 3-digit number, that means 0, 0, 0. And if we will have to count with help of 3-digit number, then what we will have to do? After 0, 0, 0, there will be 0, 0, 1, then 0, 0, 2, then 0, 0, 3, and this will continue up to 0, 0, 9. Correct? As at the least significant position, this is least significant position, and this is the most significant position of 3-digit number. As the number at least significant position will reaches to the maximum count, that is the highest number in the number system, here it is 9 because the decimal number system we are using, then what we will have to do? We will have to reset this 9 to 0, and then we will have to increment the next significant digit by 1. And therefore I will increase this 0 to 1. Now this will continue up to 0, 1, 9. Correct? And then what I will have to do? I will have to reset this least significant digit to 0, and then I will have to increment the next significant digit by 1, and therefore it will be 2. Now we are this system is so common to us, we could not understand that we are resetting the significant digit, least significant digit by 1, and then increasing the next significant digit by 1. It is a common practice for us to count 1, 2, 3, 4, then 9, 10, 11, 12, up to 19, 20, then obviously it is 21, so on up to 99. Correct? That means up to 99. Then what happens after 99? The technique is same. What we will have to do? We will have to reset the least significant digit to 0. Then we will have to increment the next significant digit by 1. Therefore, after 9 there is no number in the decimal number system. Therefore, again we will have to reset it to 0. We will have to reset it to 0 and then increase the next significant digit by 1, and therefore it is 100. Okay. But now it is common practice for us. What is the number after 99? Normally we call it as 100. But the system or the progress is something like this. Suppose we continue in the same manner up to 568, suppose, then what is the next number? We will have to increase the least significant digit by 1. Yes, it is possible because 9 is available, and our next number will be 569. If we will have to increase this number by 1, then what we will have to do? We will have to increase the least significant digit by 1, but now after 9 there is no number in the base of the number system, and therefore we will have to reset it to 0. We will have to increment the next significant digit by 1, and therefore it is 7, and there is no need to increase the further number by 1. It remains as it is, and therefore after 569 there is 570. So on we can continue up to 999, and then again there will be a problem that if we are using 3-digit number, then there is no possibility to count the further number with help of the 3-digit number, because what will happen? To count the next number, we will have to increase the least significant digit by 1, which is not possible. Therefore, we will have to reset it to 0. Increase the next significant digit by 1, it is not possible. We will have to reset it to 0. Increase the next significant, which is not possible, and we will have to reset it to 0. And therefore, the number in 3-digit system is 000 after 999. Okay, now we can observe in case of the speedometer of a vehicle. Suppose the speedometer consists of 5-digit system, then up to 99,999 kilometer, it will reset to 0. Correct? It will count 0 because there is no sixth number to or sixth digit to count the distance covered by that particular vehicle. Now once we understand this type of number system, which is the common number system for us, and we will call this as the decimal number system. Now we will go for the binary number system. Now it is very simple. Suppose if I give you the number system whose base is any random number, say for example 5. 5 is the base of the number system, and therefore 5 distinct letters or 5 distinct symbols are to be used. The common symbols are numbers from 0 to 9, and therefore I will use the same. It is 0, 1, 2, 3 and 4. These are the 5 distinct numbers of the number system whose base is 5. Now remember that such a random system may not be of use, and therefore there is no tradition to use the number system with base 5. But how we can introduce such type of number system? I am considering this example, and therefore how there will be a progress of number in this number system. Suppose there are 3 positions. Now I cannot call this as the digit, because digit is used for the number system whose base is 10. But there is no special name for this. There are special names for the number system with base 2. It is known as a bit because it is binary digit. Okay, we will go through that number system later on. But how the numbers can be progressed in the number system with base of 5? It will be 000, then 001, 002, 003, 004. Now you will observe that after 4 we cannot write it as 005. The reason is that 5 is not included in the base of that number system. Whereas what we will have to do, we will have to reset this least significant position by 1, and we will have to write it 0, and we will have to increase the next significant position by 1, and therefore it will be 010. Now this will continue up to 011, and then continue it will be 014, and then again I will have to reset it to 0 and increment the next by 1, and it will be 020. This will continue up to 044, and then the next number will be 100. Now we are not aware about such type of number system. The reason is that we are well familiar and well acquainted with the decimal number system. Therefore it is obvious for us that after 9 the number is 10, after 99 the number is 100, and after 999 the number is 1000. We are aware about that. But if someone writes the number something like this, it is 0, 1, 2, 3, 4 and then 10, then we may call it that it is wrong, and after 4 the number is 5. Yes, it is in decimal number system, but if the number system is with base 5, then it is correct. After 004 the number will be 010. After 014 the number will be 020, and after 044 the number will be 100. Okay. Now similarly, we may think about the number system with base, any base, base 6, base 7 up to base 10. If base 11 is to be considered, then along with the 10 digits from 0 to 9, we will have to use some letters A, B, C, and it is convention. We may use certain symbols also, we may use star, we may use dollar, we may use @ sign, etc. But it is not common practice for us, and therefore it will be better to use letter A, B, C, which is used in hexadecimal number system. We will have to discuss something about the hexadecimal number system too. Okay. With this discussion about how there is a number system with certain base and how there is a progression of number in a particular number system, we will go for discussion of the binary number system. Okay, therefore now the number system which we will have to discuss is the binary number system. Now why the binary number system has the importance in digital electronics, or why this number system is useful? Why not we consider the number system with base 3, base 4, etc. The reason is that in binary number system, base of the binary system, number system is 2, and there are two distinct symbols, that is 0 and 1. We may call it as a number, but these are symbols for that binary number system. Okay, therefore and these 0 and 1 are known as bit. The reason for development of this binary number system is that the digital electronics is based on two states. We are aware about the logic gates, and therefore I can say that it is logic low and high. That means there are two possibilities, whether the signal is low or high, whether the switch is off or on, whether the light is on or off, whether the voltage is in between 0 to 0.4 volts. Say for example, it may be for the output profile of certain TTL device, or whether the voltage is in between 2.4 volt to 5 volt. It depends, and for that we call it as logic low or logic 0 and logic 1. Whether the switch is on or off, whether the lamp is glowing or not, whether the signal is carried by that particular line or not, and hence in digital electronics there are two states, and therefore the binary number system is important for the digital electronics, and hence it is the required number system. It is not the just number system with any random base, but it has the application potential. Now once we decide the base of the number system to be 2, and if we conclude that there are two symbols, one is 0 and second is 1, which are called as the bit, then we can think about the progression of the number, how the count goes on increasing by 1. Typically we may think about the 4-bit number. Now see, here you will realize that in case of the digit, here I can say that it is the 3-digit number. That means there are 3 digits. This is a digit, this is the digit, this is a digit. Digit increase from 0 to 9. Whereas here in this number system we are going to use the bit, because it is the binary number system, and hence I will have to write it is 4-bit number. How there is a progression of 4-bit number? The first number is 0000, and obviously the corresponding value is 0. Then what will be the next number for the binary number system? 4-bit number. It will be 0001, because after 0 we will have to increase the least significant bit. Now this is the least significant bit, this will be obviously the most significant bit, and these are the successive higher significance for the bits. Then for the next number, what I will have to do? I will have to increase the least significant bit by 1, but it is not possible because 2 is not there in the base of the binary number system, and therefore again the technique is same. I will have to reset this number to 0, and I will have to increase the next significant bit by 1. Therefore it will be 0010. Correct? Now we are aware about such type of number system. In 12th also we have considered how there is a progression of binary numbers, but we are not aware, we may not be aware about such type of development for any random number system with random base. Correct? Then What will be the next number in 4-bit number? It is 0, 0, 1 remains as it is. We will have to increase the least significant bit by 1, and it is possible from 0 to 1. Therefore, next number will be this. Now again the situation is something like 99. Correct? What I will have to do? I will have to increase the least significant digit by 1. It is not possible. Therefore, reset it to 0. Increase the next significant digit by 1. It is not possible. Reset it to 0 and increase the next significant digit by 1. Same technique we will have to adopt here. Here if I will have to increase the least significant bit by 1, it is not possible. Reset it to 0. Increase the next significant bit by 1, and therefore again I will reset it to 0 and I will increase the next significant bit by 1, and therefore the next number will be 0, 1, 0, 0. Correct? And now we can continue like 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0 and so on. Correct? Everywhere you will observe that first of all, we will have to try to increase the least significant bit by 1. If it is not possible, then reset it. Try to increase the next significant bit by 1. If it is not possible, then reset it and continue up to the most significant bit. And now this number system will increase up to 1, 1, 1, 1. And after 1, 1, 1, 1, it has to reset to 0, 0, 0, 0. Again, the reason is same. We will have to increase the least significant bit by 1. And therefore it is not possible. Reset it, try to increase next significant bit by 1, not possible. Reset it, try to increase next significant bit by 1, not possible. Reset it to 0, try to increment next significant bit, it is not possible. Reset it to 0, and as it is 4-bit number, there is no possibility of 5th bit here. But now to count the further, we need the 5-bit number, because the next number is the 5th bit, and which is to be increased by 1 from 0. Like in case of the decimal number system, after 999 we need a 4th digit, that is the number will be 1000 number. Same situation will be here, and this can be treated as our binary number system. Now what are the equivalent decimal values of that binary number system? Now counting is continuous, and therefore we can write this is 0, this is 1, this is 2, this is 3, here it is 4, then 5, this is 6, this is 7, this will be 8, and finally this can be treated as 15. Correct? Now remember that these are the digits with which we are familiar. This is in our normal number system, that is decimal number system, which we use for our day-to-day life discussion. But this number system with base 2 and 0 and 1 to be bit to develop the number system is known as binary number system. Now after the binary number system, I would like to introduce one more number system which is known as octal number system. Correct? Octal number system. We will discuss about the conversion from one number system to other later on, and for that, as we are aware about the multiplication, division in terms of the decimal number system, we will use the decimal number system as a intermediate number system. That means we will convert from binary number system to decimal, then decimal to octal or some other number system, and vice versa. Now what about the octal number system? We are familiar with word octal. Obviously the base of that number system will be 8, and then we should use 8 different symbols to represent successive increase in that number system. But it is the tradition, and it is very simple to use the numbers from 0, 1, 2, 3, 4, 5, 6 and 7 to be different numbers in the number system, and these are the 8 numbers. Therefore, our octal number system consists of 8 basic numbers from 0 to 7, and we can develop the number, that is the number in octal number system, with help of these 0 to 7 base numbers. How? Suppose I will have to think about the 4 digit. Now I don't remember exactly whether it is called as a digit, but it should not be called as a bit, because bit is related with the binary number system. But suppose we will have to 4 positions, say for example, then I will have to begin with 0, 0, 0, 0. Then obviously the next number will be 0, 0, 0, 1, because we will have to increase the least significant position by 1. Then I will have to write it is 1 0 0 0 2 because I will have to increase the least significant position by 1, and this will continue up to 0 0 0 7 in octal number system because 0 to 7 digits are available in octal number system. But if I will have to further increase the number by 1, I cannot write it at 0 0 0 8. The reason is that this 8 is not there in octal number system. At that time, what I will have to do, the technique is same that we have adopted for the development of the decimal number. We have used to develop the binary number. Similarly, here I can use the same technique. I will have to reset the least significant position by 1, and I will have to increase the next significant position by 1, that is 0 to 1. Here I will write it is 0 to 0. Sorry, I will have to reset the least significant position to 0, reset to 0 and increase by 1. Now the number will continue 0 0 1 1, then 0 0 1 2 up to 0 0 1 7. And again you will observe that after 0 0 1 7 I cannot write 0 0 1 8 because 7 is the highest number in octal number system. I will have to reset it to 0 and increase the next significant position by 1, and therefore it will be 0 0 2 0. Now you can try. The next number obviously will be 0 0 2 1, 0 0 2 2. We will have to continue up to 0 0 2 7. Then the number will be 0 0 3 0, 0 0 3 1. We will have to continue up to 0 0 7 7. And then we will have to think about it will be 0 1 0 0. Now it will be a bit interesting if you show it to someone who is aware about the decimal number system. Then he may say that it is wrong. Why after 27 there is 30 direct, where is 28 29? Similarly, he may ask that why after 17 there is directly 20, why not 18 and 19? After 0077, that is 77, why not 78, 79, up to 99 and then 100, why it is directly 100? But it is correct for the octal number system, correct for the octal number system. Obviously, if we are representing this number in octal number system, this number in binary number system, this number in decimal number system, then somewhere we will have to mention the base of that number system or which number system we are going to use, because the corresponding values will change. See, here we can say that it is 0011 is not the 11, it is not 11, but it has the significance or it has the value of 3 because it is third number in binary number system. This is 0, 1, 2 and 3, correct, fourth number in binary number system. Similarly, if it is 1, 1, then obviously it has no value of the tolerance of 11. This value is not 11 because it is, see, here it is 0, 1, 2, up to 7 it is okay, but then this has the value of 8. It is ninth count, therefore count is 8. Then how we will realize that whether it is 11 in here it is 11 in decimal number system, or whether this 11 is in binary number system whose value is 3, or this 1 1 is in octal number system whose value may be 9, correct? And at that time or for that, actually we will have to write this 0 1 1 in decimal number system. Here we will have to mention that the base of the number system is 10 and therefore this 11 is actual 11 in our day-to-day life. But if I write this in binary number system, then I will have to mention that it is 0011 in binary number system, means it is not 11 but it is 0011 in binary number system whose actual value is 3. Now how to calculate the actual value in decimal number system we will discuss after some time. But for the small number it is 1 1, I can count 0, 1, 2 and 3. Similarly, what is the value of 0011 in octal number system? Either I will have to write it is 8 or it is 0011. The convention is to write O. O stands for octal and whose value is see, here the value is 8 and therefore here the value is 9, correct? Therefore 0011 in octal number system is equivalent to 9 in decimal number system. This is equivalent to 3 in decimal number system, and there is no need to write this to be equal to 11 in decimal number system because we are well familiar with the decimal number system. Now exactly similar to this, there will be one more useful number system, and which is known as hexadecimal. Now the name itself suggests that there are 16 different letters or 16 different symbols are to be used to represent the number, as the base of the number system is 16. Means hexadecimal number system is the number system with base 16. Now with the background of decimal number system, binary number system and octal number system, you may think about the different development of this hexadecimal number system with background of the different numbers which are used, 16 numbers. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 digits which are used in decimal number system as it is. And then the convention is to use the 5 letters. It is A, B, C, D and E and F. These are 6 letters which are to be used, and therefore 6 plus 10, that is equal to 16, and these are the different symbols, 16 different symbols which are used in succession from 0 to F in hexadecimal number system. And therefore it is obvious how we can think about the development of a number. Now I can write in short 0, 0, 0, then it will be 0, 0, 1, but it will continue up to 0, 0, 9. But is it possible to increase 9 by 1? Yes, in hexadecimal number system it is possible, because after 9 there is a possibility of A, and hence it will continue up to F, 00A, 00B, 00C, 00D, 00E and 00F. Then what will happen? Then once we increase the least significant position by 1 up to F, then if we will have to count the next number, it is not possible. Then we will have to reset the least significant position by reset it to 0 and increase the next significant position by 1, and therefore the next number will be 0, 1, 0. And obviously this will continue up to 0, 1, F, then it will be 0, 2, 0. This will continue up to 0, 2, F, then it will be 0, 3, 0. This will continue up to 0, F, F. Now this is interesting. It is 0, F, F, and then it is like the 99 in decimal number system. Here it is 0, 99. Correct? 0, F, F. And then to count the next number, what we will have to do? We will have to increase the least significant position by 1, but it is not possible because it is the last number in hexadecimal number system. Therefore we will have to reset the least significant position to 0, increase the next significant position by 1, but again after F there is no possibility, reset it to 0, increase the next significant position by 1, and therefore after 0, F, F, the number in hexadecimal number system is 100. But again, if we will have to represent the number in hexadecimal number system, the convention is that we will have to write the number as 011 suppose, and then we will have to write it is H, or we will have to write it 011, and here I will have to write it is 16, which indicates that this is not 11, but it has the value, corresponding value in decimal number system is to be count considering the hexadecimal number system. And in this case, if you observe the progression of the number, then this number has the value of 16, correct? It is 16, because we may continue, it is 0, 1, 2, 3, this is 10, 11, 12, 13, 14, 15, and this is 16. Obviously the next number is 0, 1, 1, therefore this is in hexadecimal number system, which is equivalent to 17 in decimal number system. Therefore very interesting thing is that suppose it is 0, 1, 1 in decimal number system, then it is 11, correct, in our normal counting, that means in decimal number system. But that 0, 1, 1 in binary number system, which is equivalent to 3 in decimal number system. Here we have observed it is 0, 1, 1 in binary number system is equal to 3. Check 0, 1, 2, 3. Then 0, 1, 1 in octal number system is equivalent to 9. Here we have observed that it is 0, 1, 1 in octal number system means 9 in decimal number system. and 011 in hexadecimal number system, which is equivalent to 17 in normal decimal numbers. 011 in hexadecimal number system is 17 in decimal number system. This indicates that though we are considering the decimal number system or any other number system, it is better to specifically mention if there is a possibility of confusion between the number systems. Now what happens in our normal routine? We follow the decimal number system itself, and therefore there is no need to specify it again that we are using the decimal number system, and therefore we used to write the number 3, 9, 17, 11 instead of writing is at 1, 7 in decimal number system. Correct? Now this is about the number systems with reference to our regular number system, that is decimal number system, how there is progression of numbers in that particular number system we have discussed. Then we have gone through the binary number system whose base is 2. There are 2 bits, 0 and 1. We had gone through the importance of this in digital electronics. It is bit essential. Then we have gone through the octal number system. Now this has one more importance. We will discuss this later on. It is with base 8, that means 0 to 7 numbers are used for development of this number system, how it can be developed. And then the hexadecimal number system. Again, the hexadecimal number system has certain importance, and therefore we had considered. We have not gone through the number system with base 11, 12, 13 as we want, or we have not gone through the number system with base 18, 19, etc. But the hexadecimal number system we have considered. The reason is there, some proper reason is there. This number system has some importance in development of the electronics or some programming in digital electronics. Now we will discuss the conversion from binary number system to decimal number system and vice versa in the next video. Thank you.